Hello everyone, this is Mohammed Al Zamel and today I will be talking about DNA replication. Before we talk about replication, we need to know what is DNA. DNA or deoxyribonucleic acid is the genetic material of all living things and it has the structure of a double helix. This structure was proposed or introduced by Watson and Crick, who also proposed the method of replication, which is the semi-conservative replication. As you can see here, the double helix has two strands or two outer strands and the bases inside. The bases we have are adenine, thymine, and cytosine and guanine. The DNA is composed of a sugar called deoxyribose, a phosphate, and one of these nitrogenous bases. As DNA is a nucleic acid, it is composed of nucleotides. The nucleotide structure is a phosphate, a sugar, and a base. We have two types of bases or nitrogenous bases. We have the purine bases and the pyrimidine bases. The purine bases, we have adenine and guanine. For the pyrimidine bases, we have cytosine and thymine. Thymine is only for the DNA. Now we can talk about replication. As I said, it is called the semi-conservative replication. This process has three steps, which are the unwinding, the base pairing, and finally the joining. Today I will be talking about the unwinding and the base pairing. For the unwinding, an enzyme called helicase is responsible for unzipping or unwinding the strands. And after having the strands separated, a group of proteins called single-stranded binding protein is added to keep the strands separate during the replication of DNA. After having the proteins added, another enzyme called RNA primer or primase adds a short segment to each strand, which is called the RNA primer. After the unwinding stage, we have the base pairing stage, which was at first the DNA polymerase synthesizes the addition of proper or catalyzes the addition of proper nucleotides to the new strand or the complementary strand. As you can see here, we have two types of strands. We have the leading strand and the lagging strand. The leading strand is synthesized continuously, but the lagging strand is synthesized discontinuously. Nucleotide segments are left, which are called the Okazaki fragments, which are later connected by the DNA ligase. The leading strand, when the DNA double helix is unzipped, elongates, and for the lagging strand, it elongates away from the replication fork or the place or the area where the replication occurs. Now, after explaining this photo, we can draw the parental strand and the complementary strand to explain it in depth. As the parental strand, it usually looks like this. We have the other parental strand would look like this. Then we would have the bases. For example, here we have A, T, and G. As we have here the bases we want to use, we need to follow the rule called the Shargaff rule, which says that A is equal to T and G is equal to C. So here we can add T to base pair with the A, and A to base pair with the T, and finally a C to base pair with the G. Now we unwind these two strands by drawing the two strands. We would have this strand and the other strand. Then we add our bases, which are as I drew in the first drawing. We have A, T, then we would have G. This is not like a real sequence, or I just picked at random the bases. So here we will have a T to base pair with A, and A with to base pair with a T. And finally the G will base pair with a C. Then in the process of base pairing, the DNA polymerase will help catalyze or synthesize the addition of new strands called complementary strands. So here I draw them in another color. The parent strand will base pair with the complementary strands. For example, here we have an A, so we base pair it with a T. Then a T will base pair with an A. Then the G will finally base pair with a C. The same process will go for the other complementary strand. And the final step of the DNA replication will be the joining step, which will be explained by my teammate Sauod Al Buaijan.
Hello and good morning, everybody. It's Sauod Buaijan talking with you today. Today we'll be talking about the prokaryotic and eukaryotic replication and comparing and sort of contrasting them. So, for starters, when we talk about prokaryotic replications, a prokaryotic area of replication will be circular, and the prokaryotic is circular. So, the prokaryotic replication are made after the helicase replication form, where the parental strand or the leading strand is formed, where, as you see here, this is the strand. Okay, this strand opens up, as you see here, which is the area of the replication. The area of replication, it is where the replication occurs. As you see, there are two arrows here. The arrows are like there are only two because the replication occurs in the opposite side, and they're always sort of opposite. And when talking in prokaryotic replication, the prokaryotic replication will be smaller than a eukaryotic replication. So now we will head to the eukaryotic replication. When talking in the eukaryotic replication happens in several times. As you see, as you learned pastly, those two big round places that I've just circled are the places of replication in a eukaryotic replication. They don't have a specific place, but I drew them here. So a eukaryotic replication also only go in two different ways, where as you see the arrows here, they are all only in two different ways, same as the prokaryotic. When talking in prokaryotic, leading strand in eukaryotic is continuous, which means that the line is linear. So now you may ask, what is a replication? So a replication is the action of copying or reproducing the DNA, but it is mostly copying the DNA. So now we will move on to comparing the DNA replication. I mean contrasting, it's a bit of contrasting. I just compared them. When we talk about the DNA replication, in eukaryotics, each individual area of chromosome is replicated in a section, which can vary in a length from 10,000 to a million base pairs. Also in a eukaryotic replication origins look like bubbles. That's why they are big. That is the place of the replication. Now we will head on to the prokaryotic replication. The prokaryotic replication remains in the cytoplasm, while in the eukaryotic replication, it is packaged in a nucleus. Now we will talk about how process of replication from the start occurs. At first, there is a leading strand and a lagging strand. Let's say this is the lagging strand. They will meet in a place called the helicase, which is namely called a replication form. This is the helicase. This in a helicase, it is where the parental strand, where a parental strand is formed. And when a parental strand is formed, the process of replication will start. Now, in the leading strand, which is the black one here, we have the DNA polymerase. The DNA polymerase moves to the helicase. While in the lagging strand, we have sort of bars which are lagging. That is why it's called lagging strand. Here is the helicase, where the helicase is formed. So in the lagging strand, those bars are called the Okazaki fragments. You may ask, what are Okazaki fragments? They are the fragments that when you see they are lagging. Those are the Okazaki fragments. And that is how the replication is formed, where it starts from the leading and lagging strand, and then they pass the helicase, and the helicase, after the helicase replication fork, the parental or leading strand is formed. Thank you for listening, and have a wonderful, great day.
Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah salatu wassalam ala rasulullah. Hello, I will be explaining today the similarities between DNA replication and the liberation celebrations that we are doing now. DNA replication, as previously explained by my teammates Mohammed Al Zamel and Sauod Al Buaijan, is that there is a new strand and the original strand as presented here on the right with the picture. And there is a link. There's a link between the DNA replication in general and the traditions and the change of traditions here in Kuwait, and how it links with the Liberation Week as well. So there are three types of links or similarities I can explain today. So as explained is that DNA replication is similar to Q8 celebrations. Okay, sorry if it's a bit messy. So DNA replication is similar to the Kuwait celebrations. So how is that? First of all, we need to explain the three types. There is number one, internal, number two, external, and number three, external. So the first type, internal. Internal, as we can explain, is that there is a new strand and an original strand, the complementary strand and the parent strand. The parent strand, we can link that to the old traditions, to the old generation of parents, of grandparents, of, let's say, generations between the 1940s and to the 1980s. This is the parent strand. This is the original parent. These are the original traditions, the old traditions. The new strand is the complementary strand. The new strand is, we can say, from the 1990s to currently, with our age. This age group is, we can put it with the complementary strand. We can put it with the complementary strand. And another way we can explain this is that the complementary strand would have never been created or in place without the original parent strand. It would have never been in place or created without the parent strand. So in order for this complementary strand to be created, the parent strand needs to be in place. The parent strand needs to be available. And for this to happen, DNA replication has to take place as previously explained. So the new generation, or the complementary strand between quotations or between brackets, would have never been in this success or with these achievements or with these accomplishments. This generation from the 1990s to the 2000s basically would have never, or to the 21st century, would have never been this successful, or would have never been this technologically not advanced, and with this type of advancements or accomplishments. It would have never been possible for this new generation to acquire or to achieve these things without the success, without the traditions, without the achievements, without the accomplishments of the old generation, or between brackets the parent strand or the old strand. So it would have never been in place, it would have never been available or created without the original parent strand, without the original parents of Kuwait, of the traditions of the Kuwaiti population. So as new generations occur, or as new generations populate, as with any other society, there will be new generations or new traditions to be in place or in store. For number two, external. External is not that external. We are still looking inside the nucleus. However, I would personally say that when the DNA multiplies, when the DNA replicates over and over, more and more, the DNA numbers have multiplied. The DNA numbers have increased. Therefore, we can have some form of similarity with the Kuwaiti population or with the Kuwaiti traditions. Most countries, when they experience a war or when they experience a civil war, for example, most countries stop, or most countries take a pause, or most countries, they have some form of like a shell shock. They can't recover. However, Kuwait has recovered. Kuwait has been a better Kuwait than it has been before. Kuwait has been a better Kuwait than it has been before. Much better. So you wouldn't find that in other countries. Nevertheless, some countries have also recovered, not just Kuwait. However, Kuwait has excelled beyond and has recovered beyond expectations. And this is the same. When DNA multiplies, it's the same as when knowledge multiplies here in Kuwait. When traditions exceed, when traditions multiply and add and get more and more diverse. So you'll find traditions and knowledge never stopping. Just like how DNA replication never stops, unless the death of the cell or the death of the person as a whole. Last thing is the extra external. The extra external is like how when a person completes childhood or infancy, and he has completed his DNA replication, and he gets his facial features, his body features. Okay, so slowly but gradually, slowly and gradually, the person will slowly get his facial features, his body features, either manly features or feminine features. Slowly and gradually, the person gets these features with the multiplication or the replication of DNA. The same happens with Kuwait. As DNA multiplies, as DNA replicates, we can put that as the same as the knowledge and traditions of Kuwait. As traditions multiply and as traditions continue to grow and replicate here in Kuwait, between the old and new generations, both have their own features, both have their own traditions. You'll find that there is a mix between the old and new, and Kuwait becomes a whole unified country. Just how the DNA in the body unifies together to make the entire person, to make the entire facial features, to make the features of the person. So when the DNA multiplies, the same as the traditions multiply, the traditions continue to have a high diversity and variety between the new generation and the old generation. If they mix together to make a unified tree that houses lovely people, that houses many traditions, that houses old and new generations together unified. And thank you for listening. And now I will pass on to Nasser Bouericky, that will explain how traditions have changed here in Kuwait over time.
Hello, my name is Nasser Bouericky, and I'm here to explain the difference between old and new traditions. For our first example, we have communication. So in the old generations, they used to meet up in school so they can decide where to meet up and at what time. But in the new generations, you can contact each other on the phone, so you can set up to meet your friend. For the second example, we have all the new generation, transportation. For the old generation, most of them used to walk to school. This was before the invention of cars, or maybe cars were not that common that day, and the school was beside them, so they walked. In the new generation, we have cars and advancement in technology, so there are many ways in transportation, but most people use cars. Most people use cars to transport to go to school nowadays, but no one walks to school because of the advancement in technology. Example 3. So example 3 is tests or classwork or work in school. In the old generations, everything used to be on paper and pen, and they didn't have technology and they weren't advanced in it. So they used to write everything in pen and pencil and submit it through school, so they give it to the teacher. But in the new generation, we are advanced in technology, and most of the students or most of the schools all around the world, they use technology to assist their students. For example, they can give work, or they can give tests. They can give the tests or the work to the students online. This is easier for the teacher and the students, where the student doesn't need to tire his hand that much when he writes on paper, and for the teacher, the machine or the laptop can grade the work for him, so he doesn't have to grade the work. Thank you for listening.